All right, today you're going to be classifying triangles by angle measure and side length. So you're going to be classifying them by angle measure and side length, and then you're also going to apply those rules to some exercises so that you can find side lengths and angle measures in triangles. All right, so first, by angle measure or by angle, you've got an acute triangle. And an acute triangle has three acute angles. And an acute angle is less than 90 degrees. So it's got three of them. Second type of triangle is what's called equiangular. In an equiangular triangle, the triangle has three congruent angles. And then there's a right triangle that has one right angle. And a right angle is equal to 90 degrees. This symbol, the red half of a box in an angle, is the symbol for a 90-degree angle. That symbol right there, it means 90 degrees. And the third class of triangles by angle measure is an obtuse triangle. That has one obtuse angle. An obtuse angle is greater than 90 and less than 180. Greater than 90, less than 180. So we're going to do a couple of examples. I'm looking at example 1A and 1B on the bottom of page 224. You can look along in the book, or you can try to draw that triangle. You'd probably be more beneficial to either look along in the book or just look at the wall. They give you three triangles in that picture. And they give you some angle measures. They ask you to classify each triangle by angle measure. The first triangle they ask you to classify is triangle EHG. Triangle EHG is the big triangle around the outside. Can anybody classify that triangle by angle? Olivia? Equiangular, well, angle E is 30 and angle G is 60. See this red mark up in this corner? What does that red mark mean? 90 degrees. So what kind of triangle is this? It's a right triangle. It's got 190-degree angle. Triangle EFH. Identify the triangle. It's E to F over to H. What is angle E in that triangle? It's 30. And this smaller angle up here is, and what is this angle right here? It's 120 because it's a linear pair with the 60. So what type of triangle is that by angle measure? It's an obtuse triangle. How about FHG? Triangle FHG in this diagram. F up to H over to G. Look up here at this big angle H, the entire angle. If the entire angle is 90, right? And this much of it's 30, what is this piece of it? 60.
So that's Q.
Aren't all the angles 60 degrees?
Oh yeah, so equal angle, yeah.
Wouldn't it be equa-angular? So that's equa-angular. All the angles are equal. Classifying triangles by side length. First type of triangle is called equilateral. And in an equilateral triangle, it's just like an equiangular triangle. Equilateral, though, means 3 congruent sides. Second type of triangle by side length is called isosceles. An isosceles triangle has 2 congruent sides.
Is that S-C
ISOSCELES. Isosceles. Third type of triangle by side length is called scalene. And that has no congruent sides. None of the sides are the same. So if you look at example 2 on page 225, 2A, it asks you to classify each triangle by its side lengths. I would look at the example. I wouldn't try to, some of you guys, it seems like it takes you longer to draw the diagram that's already in your book. And then you're spending so much time trying to draw something that's already in your book that you don't really get what we're talking about. So maybe look at the example and start trying to do the example while I'm putting it on the wall, and then we can, if we have to refer to a drawing, we can refer to the one on the wall. The first triangle they ask you to classify is triangle ABC. So triangle ABC is this medium-sized triangle here on the left. remember the hash marks or the tick marks mean that two sides are the same, doesn't it? But if the left side is 15, what is side AC equal to? 15. And what is side BC equal to? 15. So what kind of triangle is that? Equilateral. Triangle ACD. ACD. That's the small triangle on the right. So it's very helpful in this case to start filling in information. Meaning, if side AB is 15 and AB and AC both have tick marks, then AC is also 15, isn't it?
Yes.
So if you look at this triangle on the right, isn't one side 15, one side's 5, and the other side's 18?
So that's a scale.
That's scalene. None of the sides are the same. ABC, ACD, and then let's look at the big triangle, that is ABD. And you could take this information here.
Isn't that also scale?
What's the length of side BD?
20.
It's 20, isn't it? The 15 plus the 5, so that's 20. So that's also scalene. Yes?
Wait, so would it, the numbers would only be 15 and 20, there wouldn't be a third?
15, 20, and 18.
Angle or triangle ABD only has 3 sides. It's got A to B over to D and back up to A.
Oh,
So
okay.
one side is 15, one side is 18, and this third side is 20. You got to add the 15 and the 5. And then the second part of your assignment today is you're going to be finding side lengths using triangle classifications. So if you look at example 3 on page 225, they give you a picture of a triangle. Oh, that's a bad triangle. I apologize. They give you a picture of a triangle. And they give you some information about that triangle, like a tick mark on the bottom and on the right-hand side. So right now, what kind of a triangle is it? It's isosceles, good. This is triangle JKL. They ask you to find the side lengths of the triangle. They tell you that side JK is 4x minus 1.3. That side LK is x plus 3.2. And side JL is 5x minus 0.2. So if you know that two of the sides are equal to each other, don't you have to solve for x to find the side lengths? So you've got to write an equation here, don't you? So can you write 4x minus 1.3? What's it going to be equal to? X plus 3.2. So I would suggest subtracting x from each side. So 3x minus 1.3 would equal 3.2. Add 1.3 to each side. So 3x would equal 4.5. Divide both sides by 3. And x equals 1.5. Once you know the value of x, then you can substitute it back into each of the expressions. And you've only got to substitute it into two of the expressions, because JK and KL are congruent. So right here you've got 4 times 1.5 minus 1.3. 4 times 1.5 is 6
Six.
minus 1.3. And what's 6 minus 1.3? 4.7. And then you can verify it. Go KL, and where there's an x, replace it with a 1.5 plus 3.2. And again, that's 4.7. And then on your third side, in your calculator, type 5 times 1.5 equals, and then push minus 0.2 equals. Ava? That's alright, but you were 7.3? Anybody's calculator say 7.3?
Yeah.
Very good. 7.3.
Why you gotta push equal twice?
You can do it your way.
Oh, okay.
So that's an
Excuse me?
That's an isosceles.
That's an isosceles. Two sides are the same. But you knew it was isosceles because two sides had the tick marks. Any questions? Your assignment for today is on page 227. Problems, let's see, you can do 3 through 19. 3 through 19, and please check headline for homework.